Hello everybody, let's take a look at Unit 4.7c, the last unit of Unit 4 and the concluding unit of WAMAP Unit 4. This is the culmination of our percents learning, and in this lesson we are going to learn about percent increase or decrease and how to calculate them. All right, so question 1, the U.S. Weather Bureau has a station on Mauna Loa in Hawaii that has measured carbon dioxide levels since 1959. At that time, there were 319 parts per million of carbon dioxide in the atmosphere. In 2005, the figure was 392 parts per million. Find the percent increase in carbon dioxide levels rounded to 2 decimal places. Okay, so make note of this, rounded to 2 decimal places. So we'll have to adjust our answer and format it that way. And then let's take a look at how to calculate this, the change. How much did it increase, the percent increase? Okay, so let's take a look at my tablet. The little formula you can use is they give you 2 sets of numbers. The first one is a reference number, and the reference number is the one that you are basing your study on. And then the new one is the number that came after the change that pushed the reference number higher or lower. So the reference number or the original number is the one that we will use for the whole total because the percent change is based on that reference number. We calculate the percent change by calculating the difference between the new number and the reference number, and difference is a mathematical term that implies subtraction. So to find the difference between the new number and the reference number, we subtract the reference number from the new number. Based on our answer, if we have a negative number, it will be a decrease. If we have a positive number, it will be an increase. Some people use absolute values here, absolute value brackets, and you know, or you can see by looking at the numbers if it's positive or negative, an increase or a decrease. But if you use this formula, the resulting number, the new number that came after the reference, after the study was started, if you get a positive number, it'll be a positive gain, an increase. And if not, then it will be, well, it could be 0 or negative. So if it's negative, it was a decrease. So I'm plugging in our numbers here. We started at 319 parts per million and grew to 392 parts per million. So to find out the difference between these two numbers, we subtract one from the other. And we can just do that with our calculator, provided we have enough power. 392 minus 319, and that's equal to 73. And we're going to divide that by the original number, the reference number, 319, and that'll give us an answer in the form of a percent. It's a decimal. It's 0.228840125. So let's jot that down. Let me just write all the steps out. So 392 minus 319 is 73. 73 over 319, and that we are setting that equal to X percent, right? X percent, X over 100, that's X per 100. That's the same as doing percent. So we set these two equal to each other to calculate what percent 73 is of 319. So I like to use cross multiplication to solve this kind of problem. And so that means we just multiply 73 times 100 and then divide it by 319 to calculate X. So I'm going to just write that out here on the side, 7300 over 319 equals X. And then I also wanted to try to show you how at WAMAP they clear the fractions, which I think it's not, I think it's easier just to do cross multiplication here to solve this, but I'm going to show you how to clear the fractions. Clearing fractions is really great when you have 3 or more elements, and here we only have 2. So anyway, let's go ahead and clear them. We're going to multiply both sides by the product of these two numbers, and we'll just write these numbers out as 319 times 100. So 319 times 100, and over here 319 times 100. And then we get cross cancellation. 319 cancels 319 on this side, leaving 100 times 73. And on this side, 100 cancels 100. And on this side, we have 319 times x. So what this means is 73 times 100 is equal to 319 times x. So we'll rewrite that way. 73 times 100 is equal to 319 times x. And the next step is to divide both sides by 319. And what we end up with, the next statement, is 7,300 over 319 is equal to x. So let's go ahead and calculate that. And this is where I got that number before, 0.228840125. And I think we don't have to write out that much. Let's see, it said rounded to 2 decimal places. Okay, so this is our decimal, and so we're going to have to move this decimal point 2 places to the right. So let me double check everything. So 7,300 divided by, let me just, this has already been done. Stop 1 second. All right, so I'm going to put the decimal point there. So 22.88400125 is the percent. So when we want to, we are rounding to? Rounded to 2 decimal places. So that means we're looking at the second decimal place, which is an 8. And the number right next to it is less than 5, so this 8 won't change, but these numbers will all fall away. And our answer will be 22.88. And that's 22.88. That will be our the percent increase. So we would write that in here, 22.88, right? And so we can check the answer here with the key, 22.88. All right, awesome. Let's take a look at the next one. An article reports attendance dropped 7% this year to 3,350. What was the attendance before the drop? Okay, so in this case, we're calculating we're trying to back calculate the number, the original number, this reference number, okay? We do it in a similar way, and this is the formula. We have our new number, so the number, they gave us the new number because it was dropped. It was 7% lower than the original number, and that's over x, which is our reference number that we don't know. And then we have 100% represents like 100%. And then the percent of change, increase or decrease. So this could be positive or negative percentage. And in this case, it dropped 7%, so it's negative. So we set it up this way, 100 minus 7 over 100. And that will tell us the percent of, that will, based on this, we'll know what percent of the original reference number this other number, 3,350, was. So let's take a look. The next step here we have 3,350 over x. So this is the new number over the source or the reference, the original number. And that's going to be equal to 93 over 100, right? Because 100 minus 7 is 93. So what this proportion is saying is that this number that we know, 3,350, is 93% of whatever number this is that we don't know yet, okay? And it makes sense because you had 100% and it went down 7, right? And it gave us this number. So this is 7% lower than this number that we don't know. That also means it's 93% of this number x. So I'm going to use cross multiplication to solve this. And we get 3, 3, 5, 0, and 2 zeros on that for multiplying by 100. And we're going to divide this by 93. And that's going to be equal to x. So let's take a look to see how we do. 335,000 divided by 93, and that gives us 3602.150538. Okay, so we're talking about population figures, right? This was attendance, so we're counting. Our unit here is people. So whenever we have people as our unit, we can't have any fractions, right? So we have to round this number in the ones column. And we follow the rounding rule, right? We go to the ones column. We look at the number on the immediate right. And if that is 5 or more, we increment this by 1. If it's not, then we don't change it and all these other numbers just fall away. So our final answer is 3,602. So that's what the attendance was the previous time, so last year. So try to keep these in mind. These are very similar setup. In one, they give you the new number and the reference number. Those are provided. And it seems easier to me to calculate the percentage change from that. So just plug those numbers into this formula and set them equal to x over 100, x percent, and then you'll get your percentage answer. If it's a negative, it went down, and if it's a positive, it went up. It was an increase, but we don't usually use a negative sign with the percentage. We just say it was like a 60% decrease. All right, and then this bottom one, the second problem today. They give you how much the change was, right? And then they tell you what it changed to, but we don't know what it changed from. So we set this up this way using 100% minus, in this case, the 7% change. And if this had been a positive change, you would do 100 plus 7%. Okay, so depending on whether it's an increase or decrease, this number, the sign of this number will change. But it was a decrease. So we learned after we did our subtraction here that 3,350 is the equivalent of 93% of this x, right? And so we cross-calculated to get the answer. All right, I'm going to go ahead and do this once. Let me move this answer. Let's see, 3602. Let me get rid of this. This is in my way. We're going to go ahead and calculate this the WAMAP way, clearing the fractions. So we're going to multiply both sides. Oops, I think we are. Multiply both sides by x and 100, right? Which is basically saying multiply both sides by 100x. All right, so on this side, the x's cancel out. On the left side, x's cancel out, leaving 100 times 3,350. And on the right side, the 100s cancel out, leaving 93x. So we have 3,350 times 100 is equal to 93x. And then if we multiply this out, we'll get 3,350, 0. So 335,000 is equal to 93x. And then we divide both sides by 93 to isolate x. And at this point, what we have looks an awful lot like what we did when we did our cross multiplication, cross cancellation to arrive at our answer. So if you want to try this to get used to doing it, it's not a bad idea. When we have more elements, it will make more sense. If you have like denominators here that are 3, 4, and 6, then you have to find the least common multiple and then multiply each of the elements by that. Anyway, give this a try. If this isn't working for you, go ahead and use cross multiplication. It's a great method. It's been working for me for years. And let's put the number in here. These are people we're talking about, so they are whole. 3,602 people. And what does the key say? Yeah, 3,602. So go ahead and try a similar question and see how you do. And if it doesn't make sense, please contact me and we can meet and chat through Zoom. See you soon. Bye-bye.